Okay, we are today starting with the next topic, intercept form of the equation of a plane. See this, we have already done this intercept form in class 11th also, but that was in 2D form. That was x upon a plus y upon b is equal to 1. But here it is three-dimensional. See here, you can see it's a three-dimensional plane passing through the points a00, 0b0 and 00c. So that is why the equation of the plane is becoming x upon a plus y upon b plus z upon c is equal to 1. Its proof is also given that is not needed. So we should always know this. The equation of the plane, that is x upon a plus y upon b plus z upon c is equal to 1. We have done this in class 11th in straight lines. So this is the question based on this concept. Find the intercept that cuts off by the plane 2x plus y minus z is equal to 5. So we are given vice versa. This is the equation of the plane is given. We are asked about the intercepts. Means we have to find the value of a, b and c. This is your question number 7 of exercise 11.3. Means this equation we have to change in the form of this. X upon a plus y upon b plus z upon c is equal to 1. So easily we can do this, just dividing the whole equation by 1. We are getting this. And just turning this into means all the negative also should be removed. That is coming in the denominator. So finally we are getting x upon 5 by 2 plus y upon 5 plus z upon minus 5 is equal to 1. So this is the equation of the plane in intercept form. So the intercepts will be a is equal to 5 upon 2, b is equal to 5 and c is equal to minus 5. So this is these are the intercepts, easily can be made in a MCQ question. It can be a 2-marker question, it can be a form of MCQ. Means you will be given with 4 options of intercepts and you can easily check it out which is the correct answer. See the next question. Find the equation of the plane with intercept 3 on the y-axis. Y-axis intercept is 3 and parallel to ZOX plane. Parallel to ZOX plane. What does this show? This means y is equal to 0. If a plane is parallel to ZOX means y is equal to 0. In 11th class also we were supposed to tell about whichever plane is parallel. So the third term is 0. If it was xy plane, then z is equal to 0. If it was yz plane, that x is equal to 0. So here it is, the equation of the plane ZOX will be y is equal to 0. And we are given the intercept of y is 3. So the equation of the plane becomes y is equal to 3. This also will not be coming in a 3-marker question. This also can come in a 1-marker or a 2-marker question. Many options can be given in the form of plane. Y is equal to 3, y is equal to minus 3, or we can say y is equal to 0. 4 options can be given and easily it can be made for an MCQ question. Now moving to the next topic. In your books, you can find it on page number 485 itself and 486. Plane passing through the intersection of two given planes. We are given here two planes. You can see here a pi1 plane is given and pi2 plane is given. We have to find the equation of this plane pi3 which is passing through the intersection of these two planes. So let us see how we are going to do this. Let pi1 and pi2 be two planes with equations. Yesterday we did this. Equation of the plane in vector form. R vector dot n1 unit vector is equal to d1 and the other is also similar one. The position vector of any point on the line of intersection must satisfy both the equation of these. Let t vector be the position vector of a point on the line. Then suppose they are just considering it a t vector which is on this line, that will be satisfying pi1 plane also and pi2 plane also. So this will become t vector dot n1 unit vector is equal to d1 and t vector dot n2 unit vector is equal to d2. Therefore, for all real values of lambda, what it will be becoming? दोनों को हमने कंबाइन कर दिया है, t dot n1 यूनिट वेक्टर plus lambda times n2 vector, because all any point which is lying on this means they will be collinear. How we write it? That a vector plus lambda times b vector. So here we are writing it n1 unit vector plus lambda times n2 unit vector and adding it d1 plus lambda d2. So the t vector is arbitrary. It satisfies for any point on this line. This line which is at the intersection, यहाँ पर कोई भी point होगा, it will be satisfying this equation. Hence the equation this represent a plane pi 3. This is the pi 3 plane. So finally, this is the equation of this plane pi 3 which is passing through the intersection of two given planes, where you should be knowing what is your n1 vector, what is your n2 vector, what is d1 and what is d2, and you can easily put the values. Similarly, putting it in the Cartesian form, all the values if we put it here, n1 vector is a1i plus b2j plus c1k. Those who were not present yesterday, they maybe not be knowing how we are describing this n1, n2. n2 vector is equal to a2i plus b2j plus c2k, and r vector is xi plus yj plus zk. If we substitute all these three values in this given equation of the vector form and solving it, I am getting here as a1x plus b1y plus c1z minus d1. This is the equation of the first plane plus lambda times equation of the second plane is equal to 0. So this is the Cartesian form of the equation of the plane passing through the intersection of two given planes for each value of lambda. Now let us see how the question is going to come. This is your question number 9 of your exercise 11.3. Find the equation of the plane through the intersection of the planes this, and the point is 2, 2, 1. So the planes are given 3x minus y plus 2z minus 4 is equal to 0 and x plus y plus z minus 2 is equal to 0. So the equation of the plane that is passing through the intersection, we can write it like this. Here they had used in place of lambda, another sign is there, you can put their lambda also, they had used their alpha. The plane passing through the point 2, 2, 1. So we'll be substituting in place of x, y and z as 2, 2 and 1, because this is the point which is lying on this point of intersection. So it will be satisfying. Why we are doing this? For finding the value of this alpha. So after putting the value, I am getting alpha is equal to minus 2 upon 3. This minus 2 upon 3, I'll be substituting back in equation number 1 and solving it by taking the LCM, so that we can get this final equation of the plane. This is your 9th question of exercise 11.3. Let us see one more question of same concept. Question number 10. Find the vector equation of the plane passing through the intersection of the planes. Now these planes are given in the vector form and through the point 2, 1 and 3. So what we will be doing this? These are the two equations of the plane, considering as 1 and 2 and putting in the final plus lambda times, this is your first plane, this is your second plane. Substitute kar diya. Now it is passing through this point 2, 1, 3 means this will be satisfying. So in place of r vector, why they are not substituted? Okay, in place of r vector, it will be substituting it 2i plus j plus 3k. It should be plus 3k. 2, 1 and 3, yes. 2i plus j plus 3k and solving it. Inside we had already collected all the values of I, of j and of k. Now we will be finding the dot product of this. How this is coming? This is your this formula जो अभी हमने पढ़ा था. This is n1 vector plus lambda times n2 vector is equal to d1 plus lambda times d2 vector. From there it is coming. This is your d1, n1, this is your n2, this is your d1, this is your d2, and substituting all the values, and now putting the value of r vector also as 2i plus j plus 3k. This is not a minus 3. This is plus 3k, and just simply multiplying it. It's a dot product, so I dot I is 1 and j dot j is 1, k dot k is 1, and we are getting this. Lambda is equal to 10 upon 9. Putting this value of lambda in equation number 3. This is the equation where we have to put so that we can finally get the answer in the vector form. So R vector dot 38i plus 68j plus 3k is equal to 153 I am getting over here. So whenever the question is given in the vector form, the answer is also coming in the vector form. Unless and until they don't mention it, you have to write the answer also in the Cartesian form. Like in the previous question, it was given in the Cartesian form. We found the answer in the Cartesian form. Here the question is given in the vector form. We found the answer in the vector form. Nothing they had mentioned here. Moving to the next question. Find the equation of a plane through the line of intersection of the planes. Again, the two planes are given in the Cartesian form, which is perpendicular to the plane x minus y plus z is equal to 0. Ultimately, intersection only. So this is the first plane, this is the second plane. Putting into the equation of first plane plus lambda times second plane is equal to 0, and solving it, collecting all the values for x, y and z. Now the direction ratios are of this plane are 2 lambda plus 1, 3 lambda plus 1 and 4 lambda plus 1. These are the direction ratios. These are perpendicular to this plane x minus y plus z. The direction ratios of x minus y plus z is 1 minus 1 and 1. When the two planes are perpendicular, the direction ratios, their product and doing the sum is equal to 0. So A1 means 2 lambda plus 1 into 1, and A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Using their DRs. Why we are using this? So that we can get the value of lambda. That is why the condition was given that this third plane is given perpendicular. In place of giving you the point, they had given you the equation of the plane. Now just finding this, the value of lambda is equal to minus 1 by 3 and substituting it back in this equation, equation number 1. I am getting here is x minus z plus 2 is equal to 0, which is the required equation of the plane. Moving to the next topic, coplanarity of these two planes. Till question number 11 of your 11.3 exercise, these were the concept. Now for coplanarity, let us see. The two planes are given by Moving to the next topic, coplanarity of two lines. Let the given lines be r vector is equal to a1 vector plus lambda times b1 vector. You can also see into your books on page number 487. And r vector is equal to a2 vector plus mu times b2 vector. This line is passing through the point say A with position vector a1 vector and is parallel to b1 vector. Line 2 is passing through a point B with position vector a2 vector and is parallel to this b2 vector. I did not show the diagram. Thus AB vector is equal to a2 vector minus a1 vector. How we used to find it? AB vector means a2 minus a1 vector. The given lines are coplanar if and if AB vector is perpendicular to B1 cross B2 vector. According to this, these two given lines are coplanar to itself, one another, if at all this AB vector, these two vectors are perpendicular to B1 cross B2 vector. So AB vector dot B1 cross B2 is equal to 0 because their dot product is 0 if they are perpendicular. And putting the values here, AB vector, it is becoming A2 minus A1 vector dot B1 vector cross B2 vector. So ultimately this is the condition which you have to prove is equal to 0 for being the two lines to be coplanar. No questions are given on this basis. Cartesian form, the 2 points are x1, y1, z1, x2, y2, z2, and substituting all the values over here. This is the front row is x2 minus x1, y2 minus y1, z2 minus z1, which is coming from your a2 minus a1. And the a1, b1, c1 and a2, b2, c2 for this b1 cross b2. Again, what we are doing here, a scalar triple product. A dot b cross c. How we used to find it? A dot b cross c using this. A determinant and not a. See on page number 488, angle between two planes. See here, the two planes are being shown. They had tried, because since a plane is a three-dimensional figure, but they had already tried to show it in their best form. The angle between the two planes is defined as the angle between their normals. See here, N1 is the normal of this plane, plane 1, and N2 is the normal of plane 2. So the angle between these two planes means the angle between their normals. How we are supposed to find it out? The two planes are given by r vector dot n1 vector is equal to d1 and r vector dot n2 vector is equal to d2. Theta is the angle between their normals to the planes, and drawn from some common point, we are getting cos theta is equal to n1 dot n2 vector upon modulus of n1 and n2. This is similar to your previous formula when we were supposed to find the angle between the two vectors using their dot product. Similarly, we are finding, because here n1 and n2 are perpendicular, so accordingly we are finding here the value of cos theta. The planes are perpendicular to each other, so their dot product is equal to 0 and parallel if n1 is parallel to n2. Now changing this whole cos theta in the Cartesian form. So the first plane will become a1x plus b1y plus c1z is equal to d1, and the second plane will be a2x plus b2y plus c2z is equal plus d2 is equal to 0. These are a1, b1 and c1, and a2, b2, c2 are the direction ratios of the normal to the plane. Putting this dot product over here, we are getting a1, a2 plus b1, b2 plus c1, c2 is equal to, and upon a1 square plus b1 square plus c1 square and a2 square plus b2 square plus c2 square. Just changing this in the vector form. This cos theta is in the vector form, and this is in the Cartesian form. Just changing that same thing into the other form. Now what else? If the planes are at right angles, then this numerator will become 0. Obviously cos 90 is 0. So then only it can be is equal to 0. If we prove this is equal to, we can say that the planes are perpendicular to each other. And if their ratios are equal, we can say that the planes are parallel to each other. So the next question was there on this basis. See here, find the angle between the planes whose vector equations are given by this. R vector dot, this is your n1 vector, is equal to 5. R dot, this is your n2 vector, is equal to 3. So you are having n1 vector, you are having n2 vector, and just finding the value between these two vectors. Cos theta. Putting the values n1 dot n2, I am getting here a minus 15, and then finding out their determinants. Root 17, root 14, just modulus, and substituting the values, I am getting here a 15 upon root 731 value. The angle between two planes with the formula which we did just now, n1 dot n2 upon magnitude of n1 into magnitude of n2, and this was your question based on this. Now moving to the next topic. Distance of a point from a plane. Question number 13, you can see. In the following cases, determine whether the given planes are parallel or perpendicular, and in case they are neither, find the angle between them. So first you have to check their perpendicularity, or if they are parallel. See this. Just now we had done, this is your A1, B1, C1, and this is your A2, B2, C2. Just multiply this and tell me what about this first question, A part. What we are getting, is they parallel, are they perpendicular, or we can find an angle between them? Just check it out fast.